Hello, welcome back. So today we'll be attempting to make a maze generator from the previous project that we made that we used to render 3D scene on Laravel, Vue, and Babylon. As you can see from the intro, that's the entire maze generator that I have made, and I would like to share with you guys. So what's the concept behind all of this maze generator? It's actually pretty simple. So the things you'll be learning today is actually object-oriented programming, OOP. How do you manage them? Second thing, the most important thing in this entire maze generation is data structures and BabylonJS, as you need it to render the scene. Algorithms, so what is a recursive backtrack algorithms and how do you actually manage algorithms? And some mathematics. You also can be learning some recursive functions on how do you actually manage them. The technical terms for this sounds quite complicated, but it's very simple. I'll walk you through that. And the entire structure program should be quite simple. The first thing that we need to think about is we need an entry point. So where the application starts and where the application ends. Same goes for we need a maze cell. After we got a maze cell, we need a maze generator or / manager. So first class we have maze cells. So what kind of properties that maze cells have to hold? So first thing maze cell needs is a floor, right? It sounds stupid, but a cell needs a floor. And the most important element over here is actually all the colorful walls next to it. So we need to store the walls as well as properties. And they need a neighbor. So let's say this is cell 1. I need a neighbor of cell next to it and below it. Something like that. So I need to know who are my neighbors. And I need to know if this cell is visited or not by the AI when it's doing all the recursion function and stuff like that. We will talk more about this later. You will know why this neighbor and visitor is quite important for this project. Next, we need an index. So is this cell at 0, 0 or is this cell at 0, 1? Depending on how you actually format your code, that's how the cell is going to look like. And coordinates, this is kind of optional, so in which part of the world position is this cell at. I'm not storing that in this project. You guys can store it in this project. I'm just going to leave it at that. I'm just going to store my index. And I also want to know the point of interest. So let's say you want to put chess or you want to spawn a monster here. So how do you know that that is a point of interest? How I did it was I showed a big yellow stick over there to let it know that this is actually a point of interest. Depending of if you want to put it as a end game goal or maybe a chess spawning area or maybe some death traps, so it's actually doable. That's how I actually keep track on what is a point of interest. So the next class that we need is maze generator. So the first thing that maze generator needs is seed. Essentially it's like Minecraft. If you give it a seed, it will always generate the same thing, because random generation is not really random. It's a mathematical calculation, a very complicated topic that I am not very sure of it myself, but yeah, you can check it out online. So next we need a width and height. So how wide and how long do you want to have the maze as? It can go like a rectangle shape. I'm not making octagon and stuff like that. I'm just gonna make it as rectangle. You guys can do that, but I'm gonna go with the easy route. So we need a cell stack. So essentially a stack of cell of which cell has it been visited and which cell it's not visited yet, and all of the cell that's generated as well. So I need to know what's my current cell visitation and also what's the previous cell that I have visited for the recursion function later. God damn it, I can't speak. and I need to know all the cell, like what I said, all the cell that's generated cells, all the cells, and I need to notify cell of their neighbors once everything is done. Let's say I spawn cell 00. Once cell 01 spawn, I need to notify its neighbor, which is 00, that 01 has spawned, and I need a function to actually visit cells, and I need a backtracking, since it's called a recursion, backtracking recursion function. So I need a way to backtrack if it reaches a dead end. So how does all this thing works? It's basically I need to know where's my north, I need to know where's my south, and east and west. So from this point of view, as you can see, I put 2 as north, I put 0 as south, while I put 1 as west and 3 as east. This might not be the best practice, but this will get the job done quite easily. So just make sure that you keep track on 0 as south, 2 as north, and east and west over here. That's how I actually keep track on all of my walls. And this is the width of the entire maze. So from here you can calculate 1, 2, 3, 4, 5. I think it's 10 by 10 from this image. And all of this yellow colored thing is the point of interest that I was talking about. And if it's pink color or purple, I'm not very sure what color was it, it's indication that it's been visited. And if cyan, it's a point of interest of the area. So this is a width and this is a height. So 0, 0 is here, and this is a width and height of the entire maze generation. So as for neighbors, it's actually a very simple topic. I have neighbors on my south. It goes something similar to the wall. 0 is south, 1 is west, 2 is north, and 3 is east. And as I visit to my south, I will be deleting the south wall and the north wall for this guy. So I'll be deleting 2 walls for this guy. And same goes for west, north, and east. So they will be deleting the walls as they visit to the next cell. Something like this. So if I were to be visiting that cell, that particular cell, which was cyan, now it turns to purple, which is visited, cyan is currently visiting, I will be deleting the wall in between them so that it will look like it has a path across it, which it has a path across it if you add a collision to all the walls. You probably could done some optimization during the generation path, where if you know that there is when during the notifying of the neighbor, you can actually delete one of its wall, and during visitation you can just delete one wall instead. But I'm lazy, so 2 walls, yeah, sure, why not? So how does a backtrack recursion algorithm actually goes? It goes this way. It's actually quite simple. So let's say you visited cell 1, and you visited cell 2, cell 3, cell 4, cell 5, and so on and so on. And suddenly you're stuck. There is no path anymore. That north, south, east, west, everyone is visited. So there is no path for you to go. And what do? You backtrack and you check. Does this cell has a visitor? Does this cell has a available cell for me to visit? No. So you backtrack it. You check the previous cell until one of it is green. Then you continue your function of finding a random neighbor to do your random maze generation again. So how it goes is, I'm stuck here. So I got no choice but to go back and check if there's any neighbor. Nope. Go back again. Check again. Is there any neighbor available? Yes. Then you continue the backtrack recursion algorithm once again. So like over here, there is no more neighbors. That's why I will be backtracking all the way and find if there's any cell that still have empty neighbors. If all of the cell is empty, that's when I call the entire algorithm a complete algorithm. So that's all about the theories and philosophy behind this entire maze generation. Alright guys, so I think that's about it for part 1. I figured that the video might be kinda taking too long right now. It's been 10 minutes and the practical part takes about 40 minutes, so the entire video might be about 1 hour long. But if you guys like this and you would like to check out part 2, which is the practical part and how I explain each code, what does it does and stuff like that, please like and subscribe. But anyway, I'm gonna be linking my source code in my description below. You guys can check it out. If you would like to see part 2, please like and subscribe. Thank you very much for watching. Hope you have a nice day and stay safe.